Hello everybody, in this video we are going to continue to use different laws of exponents to simplify expressions. So in all of the previous videos we talked about the different vocabulary words, we talked about what to do when we have a zero exponent, what to do when we have a negative exponent to change it to a positive. We also looked at some product rules, what they look like, how to set those up, and how to simplify those down to our final answer. The same thing with the power rule. So I just want to kind of show you what we have here. So the product rule is when we're taking different expressions and multiplying them with each other. So in that case, we're going to have to separate everything and organize everything and then combine their exponents. The power rule is when we have a set of parentheses and we have coefficients and exponents inside, but we also have an exponent on the outside. That one is actually going to require us to multiply exponents. And then our quotient rule is a problem that already starts off as a fraction. So if you're looking at your problems and you realize this one is already a fraction, then most likely it's going to be your quotient rule. So the quotient rule is we are organizing it just like we did. But this time we're organizing the x's, the y's, and the z's on the top and the bottom. We're lining them up. And then we're trying to make a decision on which one of the two we're going to move. Once we move one, we have to change the sign. So we can then combine those exponents. So the first example here, I have written down, so I'll give you guys a chance to write it down. Most of the time on the quotient rule, especially on the ones on your practice, they're all going to be bunched up together. I highly recommend that you rewrite it and space everything out. Alright, the second thing, when you write these out, you want to make sure that the coefficient on the top and the bottom are in the same column. So if I had a 2 on the top and a 2 at the bottom, they need to go stacked on top of each other. If you have an x on the top and an x at the bottom, you want to move it around to where they're stacked, one on top of the other. Second, make sure that they have an exponent. The one on the top has a 3. The x at the bottom doesn't have an exponent, so it's an automatic 1. So make sure that your variables all have exponents. Alright, take your two y's, make sure that they're stacked. One on top is a 4, the one at the bottom is a 2. And then our z's are also stacked. Now, the quotient rule, you have to make a decision. We cannot combine the x's together unless they're on the same side. They can both be on the top or they can both be at the bottom. So because we don't want any negative exponents, I'm going to ask you to move the smaller number to wherever the bigger number is. So in this case, let's start with this one. I want you to ignore the x's, the y's, and the z's, and we're going to just treat this as a fraction. So if you don't feel comfortable simplifying fractions, remember you can grab your calculator, you can hit Control Division and put your fraction, and it will simplify it for us. So we know that 2 over 2 is 1, but if you have other numbers or bigger numbers and you're not sure how to simplify that fraction, just type it in your calculator. Your calculator will tell you that this becomes a 1. So because it is no longer a fraction, I'm going to ask you to take the 1 and put it on the top of our new fraction. So it's going to be a 1. So we no longer have 2 over 2. It became the 1. Alright, so from here, we have to make a decision. We need the x's to be on the same side. I have this 3, I have this 1. The smaller one needs to be moved to the bigger one. So because x to the third is bigger, we're going to take the negative 1 and move it up. And if I take a positive 1 and move it up, the sign changes to a negative 1. Okay, don't worry about it right now. We're going to come fix it in a minute. So I know what you're thinking. We're not supposed to have negative exponents in our final answer, and we won't. So I'll show you how to take care of that. All right, let's talk about these y's. We have a 4 on the top, a 2 at the bottom. Once again, the 2 is smaller. That needs to go up. So we're going to say y to the 4th and y to the negative 2. Because when you move it, it changes the sign. Last, z's. We have a z on the top and the bottom. The 3 is bigger. It's at the bottom. So we're going to take this 2, which is on the top, and move it down. So because it's a positive 2, it's going to turn into a negative 2. So we have z to the 3 and z to the negative 2. Now, once you do this, it is time for us to do what we did for the product rule. Combine your exponents. So we're going to draw a new fraction here. You can keep the 1. The 1 is actually not necessary anymore, but I'm just going to leave it there. If I'm going to put my x's together, I'm going to say 3 minus 1, which gives me 2. We're going to say 4 minus 2, which gives us 2. And down here we have 3 minus 2, which gives us 1. This is our final answer, and I'm going to tell you why. We only have one x, one y, one z, because we combined all the other ones. No negative exponents, no zero exponents. This is my final answer. Now, please keep in mind that it doesn't matter if you move them up or down. Because if you do end up with a negative exponent, then you just move it to the opposite side. But if you always take the smaller exponent and move it to the bigger exponent, you should not end up with negative exponents. So that avoids that extra step. All right, we have one more problem we're going to look at, and let's go ahead and write that one down. All right, as you can tell, we have this problem right here. So I'm going to give you a chance to write it out. One of the things I want to point out about this one is that this one does require a little bit of rearranging. So not all of the problems that will be given to you will already be ready for them to be stacked and will be given to you in the same order on the top and the bottom. So this is a good example of this one right here. So the first thing I'm going to point out is I do have to rewrite it because the m's are not stacked, the n's are not stacked. So let's go ahead and rewrite it because I find that this helps us focus on one variable at a time. So we have two coefficients. We have 2 and 3. So those will be stacked. All right, let's start with the m on the top. So we have m, because it doesn't have an exponent, give it a 1. But when you look at the bottom, you see that you're m to the negative 1. So you want to go ahead and move it to where they're stacked one on top of the other. We're going to do the same thing with the n's. We have an n to the negative 4. And then we have an n to the second power. And then our p's, we're going to leave them where they're at. So p to the second and p to the negative 1. So the important thing here is that all your variables have to have exponents. If it doesn't have it, give it a 1, and then make sure that there are one on top of the other. Okay? So notice we have m's, n's, and p's stacked and organized. So remember what I said earlier. In order for us to avoid negative exponents at the end and an extra step of us moving it around, take your smaller number and move it to your bigger number. So the first thing I'm going to do here is I'm going to draw my line, and I'm going to focus on this fraction right here, 2/3. If you put a 2/3 in your calculator, you're going to realize it will not simplify. We cannot simplify 2/3 anymore. So leave it as 2 on top, 3 at the bottom. All right, let's talk about our m's. We have a positive 1 on top and a negative 1 at the bottom. The smaller number is the negative 1. So this one needs to move up. And when we take a negative number and move it up, it changes from a negative to a positive. So we have m to the 1 and m to the 1. All right, let's talk about these n's. We have a negative 4 on top and a 2 at the bottom. The smaller number here is the negative 4. So that one's going to need to come down. So at the bottom, we already have n to the second, but when this negative 4 gets dropped, it drops as a positive 4. All right, the last one is our p's. We have a positive 2 and a negative 1. The negative 1 needs to go up. Okay, so we have p to the second and p to the 1. And then from here, we can clean it up. So we already knew that the 2/3 was not going to simplify. But look what happens with our m's. We have 2 of them. 1 plus 1 is 2. Let's go ahead and do the p's as well. 2 plus 1 is 3. At the bottom, 2 plus 4, 6. And from here, this is our final answer. How do we know it's our final answer? Let me explain. We only have one m, one p, one n. So up here is where we had 2 m's, 2 p's, 2 n's. But when we condense them, now we only have 1. So check. Number 2, no negative exponents. These are all positive exponents. Number 3, no 0 exponents. They're all numbers, and they're not 0. They could be 1, but they can't be 0. So this right here is our final answer. And so if you do move it to the wrong side and you end up with a negative number here, just remember all you have to do is grab that number in its base and move it to the opposite side. By doing that, it will change your negative back to a positive, and then that would give you your final answer. All right, that was the quotient rule. It's all about looking at your problem, organizing your problem, and then finding a way to simplify it all the way to the end. Okay, so I hope these 2 examples have helped. I hope all of these examples have helped in the previous video, and I'll see you in the next videos.